Hello everyone, and thank you for joining today's session on Design of Concrete Elements in STAAD.Pro Connect Edition using Integrated Concrete Design Module. Myself Surajit Ghosh. I am a structural engineer and I have been working in Bentley Systems for more than 10 years. Today we will discuss about concrete design facility in STAAD. First, we will talk about the batch mode of concrete design, its pros and cons, when this module can be used. Then we'll cover the new and enhanced features of concrete design in Connect Edition. We will discuss about advanced concrete design module, an overview of beam, column and shear wall design in this module. I'll show you how easy and user-friendly this new module is compared to the old batch mode. One of the most important feature of this module is the custom drawing file generation. Obviously, we will cover that in details. In earlier STAAD version, including all V8i versions, there were two concrete design modules available. First one is the batch mode of concrete design, and second one is the RC designer mode. In batch mode of concrete design, the design is based on analytical member. So, if a primary member is divided in multiple segments due to secondary member or finite element meshing, then program treats each segment as a separate member. When design is performed, program considers the analysis results and provides reinforcement value for individual member. The problem is, in reality, these beam segments are not separate, rather, they are part of a continuous member. So, when different reinforcement values are provided to adjacent members, it is not feasible in sight. You need to manually adjust the reinforcement to provide a uniform reinforcement throughout the member length. The second major problem in this module is visualization. Once a beam or column is designed in this mode, you can get a detailed design result in output file. This report consists of analysis and design results in each 13 intermediate design points, but doesn't provide any diagram which represents the reinforcement distribution. For some codes like ACI in member query box, main reinforcement arrangement diagram for beam is provided in a very simpler way. For column, just a cross-sectional view is provided. Neither tabular format output or elevation and cross-section diagrams are provided. To generate the deliverable drawing files from these results is a tough job and also time consuming, as you need to first collect the reinforcement information for each segment, then rearrange manually, and finally generate the drawing files. Only for simpler and small scale structure like pump house or small stockyard structure, this module can be used. There are another concrete design module available, RC Designer mode, which can perform physical member design. But you need to manually create the physical members first, and design reports were also not that elaborate. So this module was not maintained properly and finally discontinued in Connect Edition. To solve all these limitations and make concrete design module more user-friendly and advanced, a new module was introduced in Connect Edition, Advanced Concrete Design Module. In Connect Edition, there are two modules for concrete design, this advanced module and also the old batch mode of concrete design. I don't want to spend time discussing about the batch mode. Just two updates. ACI 318-2014 and IS 13920-2016 code has been implemented in the batch mode, and Euro and British codes are removed from this module. So if you want to design any concrete member using EC2 or BS code, then you have to use Advanced Concrete Design module. Those codes are not available in the design code list in batch mode. Coming to the Advanced Concrete Design module, it was previously available as a separate software named RCDC. You can still use RCDC standalone version and import analyzed STAAD model to perform member design. Apart from that, it is now directly integrated with STAAD, and you can switch to this mode once the analysis is over. You can access this mode with three licensing options. If you have a RCDC license, then you can use that. Else, with your STAAD license also, you can use this mode. You can use the basic features of this module using your basic STAAD license. You can design beam, column or wall, check the drawing files or copy the reinforcement table, but some advanced features like saving the drawing file, including the BBS file generation, or performing crack width checks and tank design are not possible with the basic license. If you have STAAD Advanced license, then you can use all features of this module only if you use Connect Edition. So if you have STAAD Basic or Advanced license and still using the V8i version, then you cannot access this Advanced Concrete Design module. If you want to use this module, simply upgrade to the latest Connect Edition version. That's all. STAAD Advanced Concrete Design or RCDC module can perform design and detailing of any concrete entity, from beam, column, slab, shear wall to few types of foundation. RCDC can perform design and generate drawing files. For shear wall, you need to model it in STAAD using parametric mesh with wall option selected, and depending on the finite element analysis results, design is performed. RCDC uses the panel method for the design of slabs and does not carry out any analysis. The bending moments and shear forces for design are calculated based on the empirical method for design. You can also design isolated and pile cap foundations in this module. In latest version of RCDC, which is version 10, water and wastewater tank design has been included. You can import the tank module directly from STAAD and perform the design here. Several international design codes has been implemented in this module. For American code, ACI 318, 11 and 14 codes are available. Latest version of Indian code IS 13920-2016 is also available for ductile detailing. Both British and Euro codes are available along with different national annex like Malaysian, UK and Singapore national annex. In latest version, Philippine code is also implemented along with tank design module for which Eurocode is available as of now. Several advanced design checks like drying shrinkage check or crack width checks are also implemented for tank design module. Aswati will discuss this later. RCDC has a direct link with STAAD. You can either directly launch this module from STAAD interface using advanced concrete design option, or you can launch RCDC standalone version and import analyze STAAD model. Also, concrete structures created in RAM structural system and ETABS can be imported in RCDC for design. Note that RCDC imports the member and plate information along with the design forces from the structural model. There is no separate analysis engine available in this module. So you must analyze your structure first before importing it to RCDC. Another great advantage of this module is it can autoform the physical member. When you import a model in RCDC, it reads member property, geometry, location, orientation, every detail specified in structural model. If the members are divided in several segments, then RCDC internally forms the physical member depending on the imported model information. You don't have to create these physical members manually, but you can always check and rearrange the connectivity as per your requirement. As the design is based on physical member, so a realistic reinforcement layout is calculated throughout the member length. Once the design is completed, you can generate design outputs in various formats. First, a table is generated with all the calculated reinforcement information, including main, shear, and side face reinforcement. For column, steel percentage is reported in this table. Not only that, design status is also color coded in the table so that you can easily understand which member fails in design. Green means the member has passed and red means failed. You can further check the failure criteria report to know the reason for failure. Apart from this table, you can also generate a detailed calculation sheet with all member details, critical forces, and design results, including the critical clauses. One important point is actual analytical member number is reported here. So if you submit this report, design reviewer can easily cross-check the results with original STAAD model. One of the most useful feature of RCDC is the drawing file generation. It can generate several drawing files, including plan, elevation, cross-sectional drawings for all structural components. All these drawings can be saved in DXF format. So you can easily save the drawings from RCDC and then open using any CAD software to further edit it using your custom template. Ready drawings are generated and you only need to edit it before submission. Isn't it great? I'll show you how easy is this in next few minutes. RCDC can perform design of any custom shaped column. 3D PM curve for any column is generated and based on that, from basic principles, the column reinforcement are calculated. So if you create any custom shaped column like a flange column or a L column or say any amoeba shaped column, RCDC can design that and reinforcement are provided. For beam sections, you can design a primary or secondary beam as a flanged beam. The contribution of the slab is considered during beam design if you design it as a flanged column. The slab area is automatically determined based on the geometry and code provisions. And not only the design is performed, RCDC also optimizes the results to find more economic reinforcement arrangement. For example, without optimization, same bar size is provided, whereas after optimization, program finds out the optimum bar arrangement with multiple sized bar combinations, which produces more economic design. During design, if a member fails, you can redesign that particular section. You can check the failure diagnostic report to get an idea about the reason and accordingly modify the section or change the steel and concrete grade. If one or more member fails, you don't have to redesign the entire model. Just select those members only and redesign. Now, if you change any member section, then that must be modified in the analysis model as analysis forces will also change. In RCDC, you have the option to update the analysis model based on the change in section size during design. You don't have to remember all the change and then go back to STAAD model and manually modify everything. Rather, you can simply update the analysis model from RCDC and program creates a new model in the same location with file name R1 or revision 1. This file is the modified model, and if you want, you can further reanalyze the model and based on the changed analysis results, update the design file. It's very common to change any section size or modify any force values during the project span. In such cases, a redesign is required. In RCDC, you have the option to update the design results without performing new design or creating new model. If anything is changed in the analysis model or design forces change, you can simply update the RCDC design results. Program will internally check all the design results, redesign and compare with the old results, and accordingly update the final design outputs. In next part, I'll discuss how to design beam, column, and shear wall using advanced concrete design module with a 15-story building modeled in STAAD. Thanks for watching.